In today's discussion, I'm going to talk about quadratic equations in one variable. Any quadratic equation in one variable takes the following form. We have ax squared plus bx plus c is equal to 0. Where here, a is not equal to 0. And a, b, and c are supposed to be constants. X, the variable. Solutions to a quadratic equation can be distinct real or repeated or double roots. Meaning same roots obtained twice. Okay, and they are both real. So, but identical. Possible also to be imaginary pair. Okay. So let us have the following examples. Solve the given quadratic equation by factoring. Method. In applying factoring method, we're going to use the principle that if Q is equal to 0, then P is equal to 0 or Q equals 0 or both. Okay? So, number 1, we have 12x squared minus 23x plus 5 equal to 0. Okay? So let's see if the left side is factorable. So possible factors, we have 3x plus 5, 3x plus 5. The other factor, it's 3x minus 5. 4x minus 1. So let's check. 3 times 4, that is 12. Then x squared. Negative 20, negative 3, that is negative 23x. Then plus 5. So to solve for x, we equate its factor to 0. 3x minus 5 equal to 0. Or 4x minus 1 is equal to 0. Each equation is a linear equation. Solving this linear equation, we have 3x is equal to 5. Dividing each side by 3, we have 5 over 3. Or 4x is equal to 1. Dividing by 4 each side, we have x equals 1/4. So therefore, the solutions are 5 over 3 and 1/4. Okay? So let us have number 2. We have 9x squared plus 16 x then equal plus 16 equals 24x. What about this? So first, let's write this in standard form. 9x squared minus 24x plus 16. Okay? So here we have possible factors: 3x minus 4, 3x minus 4, or 3x minus 4 quantity squared. Okay? So equating, we get what? Its factor, since its factor is just the same, it's just the same with the other factor. So we have the root 4/3 is called a repeated root. Okay? So x is equal to 4/3. So, okay, so therefore the solution is x equals 4 over 3. Number 3. We have 2x plus 1, x minus 4 is equal to -7. We cannot solve this at instant, no? The way it is written. First, let us expand because the right side is not yet 0. So getting 2x squared, 1x, -8x, so that is -7x, minus 4 equals -7. Then we have 2x squared minus 7x. We add on its side plus 7, so -4 plus 7 is +3. And on the right side, -7 plus 7, that is 0. So let's try if this is factorable. We have 2x minus 1, x minus 3. Let's check. -1, -6, that is -7, +3, then 2x squared. Okay. So this is the correct factors of this left side. Equate its factor to 0. We have, for the first linear equation, x is equal to 1/2, no? And then for the second one, x equals 3. So therefore, the solutions are ½ and 3. Or x is equal to ½ or x is equal to 3. So let's have number 4. We have 2x squared minus 10x plus 11. So let's see if this can be solved by factoring. Is it factorable, the left side, guys? So I don't think this is factorable. No? So because to check if it is factorable, we can apply this formula, no? B squared minus 4AC. If this is a perfect square, then this is factorable. So let's check. Our B here is negative 10. Square it minus 4 times A is 2 and C is 11. So 10 times 10, that's 100. Minus 4 times 2 times 11. So that is 12, which is not a perfect square. So it means this is not factorable. No? The left side. Not factorable with integer coefficients. So 2x squared minus 10x plus 11 equals is not factorable. By what? So it's not factorable. No? So therefore, we cannot solve it by factoring method. So not factorable with integer coefficients. We can solve this by what we call completing the square. So by completing the square, the first step is to make the coefficient of x squared 1. So divide by what? By 2. So getting x squared minus 5x plus 11 over 2 equal to 0. Then the next step is to get rid of the constant term on the left side. So by adding negative 11 on each side of this equation. So getting negative 11 over 2 on the right side. And on the left side, x squared minus 5x. Then make this left side perfect square trinomial by adding 1/2 the coefficient of x. So 1/2 times negative 5. Okay, guys? So 1/2 times negative 5, then square it. So whatever we added on the left, we have to add that also on the right. So actually what we added, 25 over 4. So simplifying this, x squared minus 5x plus 25 over 4. So this is already a perfect square trinomial. On the right side, getting the LCD. So this is 4 divided by 2. 2 times negative 11, negative 22 plus 25. Okay? On the left side, that is x minus 5 over 2 quantity squared. So simplifying the right side, we have 3 over 4. Taking the square root of each side, we have x minus 5 over 2, and that is equal to plus or minus square root of 3 over 4. So simplifying, we have x equals 5 over 2 plus or minus square root of 3 over 2. So, or that is 5 plus or minus square root of 3 all over 2. Okay? So, there are two solutions. They are what? Irrational roots. No? real but irrational. So the solutions are what? So the solutions are 5 plus square root of 3 all over 2n, 5 minus square root of 3 all over 2. Okay? We can also use quadratic formula. Quadratic formula takes the following form. X is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So this is the formula to solve for the roots of equation of the form ax squared plus bx plus c equal to 0. Considering that a is not what? It's not equal to 0. Okay? So let's say we are given this equation. X squared plus x minus 12 is equal to 0. Our a here is 1. Our b is 1. Our c is negative 12. Plug in to the formula we have x is negative b, so negative 1 plus or minus square root of b squared. What is b squared? So 1 squared minus 4a, 4 times 1, so times negative 12. All over 2 times a, meaning 2 times 1. So getting negative 1 plus or minus 1 plus 48, that is 49, so square root of 49, all over 2. So x therefore is equal to negative 1 plus or minus 7 all over what? All over 2. So, or that is x is equal to negative 8 divided by 2, so negative 4, or x is equal to 6 divided by 2, that is 3. Okay, guys? So therefore, the solutions are, or the roots are 3 and negative 4. Okay? Let's have another one. We have x squared plus 4x and then plus negative 13 equal to 0. So let us use completing the square to solve this. So by completing the square, we have to make the coefficient of the quadratic 1. So this is already 1. So we can proceed. Constant term on the right side. So we add 13 on each side. So getting x squared plus 4x equals 13. And then completing the square on the left side by adding half the coefficient of what? Of 4, then square it. And then whatever we added on the left, we have to add it on the right. Actually, what we added is 4. 4 divided by 2 is 2, square it 4. So getting x squared plus 4x plus what? Plus 4. And that is equal to 17. So this is x plus 2, quantity squared, equals 17. If taking the square root of each side, we get x plus 2 on the right side plus or minus now, the square root of 17. Hence, x is equal to -2 plus or minus square root of 17. Therefore, the roots are what? -2 plus or minus -2 plus square root of 17 and positive -2 minus square root of 17. Okay, guys? What about equations leading to quadratic equations? So there are equations after simplification will become quadratic equations. So let us have the following. Solve. Number 1. We have x to the fourth minus 5x squared plus 4 equal to 0. Okay, we can solve this by what? By letting, for instance, letting y to be equal to x squared. So then, this equation now becomes y squared. Take note that x squared is y, therefore x to the fourth is y squared minus 5y plus 4 because our x squared is what? Y. So this is now a quadratic equation in what? In y. Okay? So this can be solved by factoring. Y minus 4, y minus 1, the factored form of that, equal to 0. Equating its factor to 0, we have y minus 4 or y minus 1 equals to 0. Y is equal to 4 or y is equal to 1. Okay? So if y equals 4, then we have x squared is equal to 4. So what is x? Plus or minus 2. What if x is equal to 1? I mean y is equal to 1. So we have x squared is equal to 1. So therefore, what is x? Plus or minus 1. Okay, guys? So there are how many roots? There are 4 roots. So the roots are 1, -1, 2, and -2. We can also write the solution set. No? Let's say you're asked of the solution set. So the solution set is given by this. Set of all x such that x is equal to 1, -2, 2, or -1, 1, -1, 2, or -2. Okay? So this is the solution set. Number 2. We have x to the fourth plus 13x squared. And then plus 36 equal to 0. So again, let what? Let's say let t be equal to x squared. So getting what? Then we have t squared plus 13t plus 36 is equal to 0. Let's see if this is factorable. We have t plus 9, t plus 4, right, guys, is equal to 0. Equate its factor to 0. Okay. So t plus 9 equal to 0 or t plus 4 is equal to 0. Therefore, t is equal to -9 or t is equal to -4. If t t is equal to -9, then what is our x squared? That is -9. So x therefore is plus or minus 3i. Okay? What about if t is equal to -4? Then we have x squared is equal to -4. X is equal to plus or minus 2i. So therefore, what's the solution set? If you're asked of the solution set, so we have 3i, -3i, the contents or the elements, 2i, then the last element is -2i. So this is the set representing the solution set of this equation. Okay, guys? Number 3. So what if we have 4x to the -4 minus 7x to the -2 minus 36 equal to 0. So we're going to let what? Here we are going to let, let's say, y to be equal to x to the -2. This equation can be written for x to the -2 quantity squared minus 7x to the -2 minus 36 equal to 0. So hence we have 4y squared minus 7y minus 36 is equal to 0. So is it factorable, guys? So let's see. So we have 4y minus, let's have 3. Let's check here. 4, 1, 3, 12, not 3, 12. No? I think it will not work. What about 9, 3? 9, 4. 9, 4. So this is 16. This is 9. I want to get -7. So this is -7, -16 plus 9, -7. So it means this one is negative. So this one. So what are the factors? So we have 4y plus 9, then y minus 4. And that is equal to 0. Again, let's check. 9y, -16, -7, -36. Okay. So then positive 4y squared. Equate its factor to 0. Y equals -9/4 for the first linear. So, or y minus 4 is equal to 0. What is y? Y therefore is equal to 4. Okay, so therefore, the solutions here are -9/4 and 4, no? But we're not solving for y actually. What we want, x. Okay, so if y equals -9/4, so our x squared is equal to x to the -2 is equal to -9/4. Okay, so or that is 1/x squared is equal to -9/4. So x squared therefore is -4/9, taking the reciprocal of its side. X therefore is plus or minus 2/3i. Okay, what about if x is equal, if y is equal to 4, then we have x to the -2 is equal to 4, or x squared is equal to 1/4. Reciprocal of x to the -2 is x squared, and then its reciprocal of 4 is 1/4. Therefore, x is plus or minus 1/2. So there are 2 real roots and there are 2 imaginary roots. So solution set, we have 1/2 negative 1/2, 2/3 I, negative 2/3 I. Okay? Any question with this? Number 4. What about if we have 100 x to the negative 4/3 minus 409 x to the negative 2/3 and then plus 36 equal to 0. Okay? So again, this time we have x to the negative 2/3. So the given equation can be written 100 x to the negative 2/3 raised to raised to 2 minus 409 x to the negative 2/3 plus 36 equal to 0. So we can write this in terms of y, 100y squared minus 409y plus 36 is equal to 0. Is this factorable, guys? So let's see. So is it a perfect square trinomial? The square root of 100 is 10. The square root of 36 is 9. Then times 2. Let's see, it's 180. So it's not, no? It's not factorable into a perfect square trinomial. Into identical binomials. So let's see what we can have for this. What are the possible factors? If you have, let's say 10, 10, 9, or it's not. So let me check if this is factorable into factors with integer coefficients. Negative b. So let's check what is our discriminant here. Negative b, negative 409 square it minus 4 times a, 100 times c, 36. So 409 times 409 minus 4 times 100 times 36. Take the square root. So it is factorable, no? So what are the possible factors? So let's try. 25, 4. And then 4, 9. Let's check. What is 25 times 9? 225 plus 16. It is 241. It's not, no? What about if 12, 3? Let's see. 25 times 3 plus 12 times 12 times 4. 12 times 4. No? So we're not able to get 409. What is it? Is it 20 times 5 and then 12 times 12 here and 3? Let's check. 20 times 12 plus 5 times 3. 225. 20 times 12 plus 20 times 12. It's not, no? It's hard to factor, no? Let's have quadratic formula. If you find it difficult to factor, although it's factorable, you can make use of quadratic formula. So negative b. So what is y? Negative b, that is negative of negative 409. So positive now, no? Then plus or minus square root of negative 409, b is squared. So negative 409 quantity squared minus 4 times a is 100. B is, negative 4 AC. C is 36. So all over 2 times 100. So 409 plus or minus. So 409 times 409 minus 4 times 100 times 36. Take the square root. So that is 391. The square root of this. All over 200. So y is equal to 409 plus 391 divided by 200. So that is y equals 4. What about the other one? So our y is 409 minus 391 divided by 200. So that is 9 over 100. Okay? So if y equals 4, so we have x to the negative 2/3 is equal to 4. Take the reciprocal, that's x to the 2/3, and that is equal to 1/4. Raise to 3 halves each side. So if you raise each side to 3 halves, so it means 1/4 raised to 3 halves. What is the a simplified form of the left side? 2/3 times 3 halves is 1. So this is simply x. So this means we have a square root of 1/4 and then raised to 3. So x therefore is equal to 1/2 raised to 3, and that is equal to 1 over 8. If x is equal to, if y is equal to 9 over 100, so what is x to the negative 2/3? That is 9 over 100. Reciprocal of each side, we have x to the 2/3, positive now the exponent, and that is equal to 100 over 9. So x is equal to, raise each side to 3 halves, no? 100 over 9 raised to 3 halves, meaning square root of this 10 over 3, then square cube it. So what is x? 10 times 10 times 10, 1,000 over 27. So the solution set therefore is set containing 1 over 8, 1,000 over 27. Okay, guys? Number 4. Let's have number 5 now. So we have x squared minus 3x quantity squared plus negative 2 x squared minus 3x and then minus 8 equal to 0. What about this? So here, you can let y to be equal to x squared minus 3x. Hence, the equation now becomes what? Y squared minus 2y minus 8 equal to 0. This is factorable into y minus 4, y plus 2. Equating its factor to 0. Then solving for y, 4 here, negative 2. So if y equals 4, then x squared minus 3x is equal to 4. X squared minus 3x minus 4 is equal to 0. So this is factorable into x minus 4, x plus 1 equal to 0, x is equal to 4, or x is equal to what? Negative 1, equating its factor to 0. If y equals negative 2, we have x squared minus 3x equals negative 2. X squared minus 3x plus 2 is equal to 0. This is x minus 2, x minus 1 equal to 0. So that's the factor for the left side. Equating its factor to 0, we have x equals 2 or x equals 1. So there are 4 roots. What are the solutions? 4, negative 1, 2, 1. Or the solution set is given by this, no? Containing 4, negative 1, 2, 1. Okay, that's it. Okay,